Hi everyone, I'm Mike Poland, the scientist in charge at the Yellowstone Volcano Observatory, and this is the monthly update for February 1st of 2021. I thought I'd start out this month's update by talking about one of the most common misconceptions about Yellowstone, and that is a big explosive eruption at Yellowstone is overdue, something I'm sure you've all heard. And this isn't true, and there's two reasons why this is the case. The first is that volcanoes don't work that way. They don't erupt on schedules. Volcanoes erupt when there's a sufficient supply of eruptible magma beneath the surface and enough pressure to get that magma up to the surface. And right now, neither of those conditions exists at Yellowstone. The magma chamber beneath Yellowstone is only about 5 to 15% molten, so it doesn't have enough to generate one of these big explosions. And over the last 15,000 years or so, since the last ice age, we know from the geology of Yellowstone Lake that Yellowstone has mostly gone down. In fact, it's gone down by a net of 30 meters, almost 100 feet over that time period. So there's no pressure and there's really no magma to feed one of these really big explosions. And even if Yellowstone did erupt on a schedule, the math still doesn't work out. Now, occasionally you'll hear that there's 600,000 years or so between Yellowstone eruption, and the last one was 631,000 years ago. Well, the last part of that's the only part that's true. 631,000 years ago, Yellowstone caldera, this red line right here, that formed. But before that was the Henry's Fork caldera, this green curve right there. That was about 1.3 million years ago, and before that was this purple line that outlines the Huckleberry Ridge caldera, and that was 2.1 million years ago. And if you look at the time period between those, the average eruption interval between these explosions is actually 725,000 years or so, which means that actually we'd have another 100,000 years or so to go. And if you go further back in time, there's even longer time periods. And if you talk about the really big explosion, Henry's Fork was actually not a super eruption. So if you only look at the super eruptions, it actually looks like the time between eruptions is getting longer. And this may be because the Yellowstone hotspot is encountering thicker and thicker continental crust. It's basically harder to burn through the crust from beneath. So it may be that we won't see near as many, or perhaps any, of these big explosive eruptions in the future, just because the hotspot doesn't have the power to get through the crust anymore. So point being, Yellowstone is not overdue. And frankly, if you hear someone on a documentary or on the internet or something say Yellowstone's overdue, you know right off the bat that they don't know what they're talking about at all. All right, let's dive in and talk about what happened during the month of January of 2021 in Yellowstone. During the month of January, the University of Utah Seismograph Stations, which is responsible for the operation and maintenance of the Yellowstone Seismic Network, located 98 earthquakes in the Yellowstone National Park area. And this is pretty normal for the region. The largest earthquake of the month was a magnitude 3.2 located near Norris Junction, and that occurred on January 6th. That was part of a small swarm of about 10 events that occurred on that date. There was also a small swarm of about 20 events that occurred on January 23rd, 24th, just southeast of Madison Junction. So this is all pretty normal seismicity for the Yellowstone region. In terms of deformation, we haven't seen much in the way of changes over the last several years. This is vertical deformation at the White Lake GPS station on the east side of the caldera, the Sour Creek Resurgent Dome, over the past 2 years. Each one of these dots is a daily data point. And because it's vertical, downward trends indicate subsidence or sinking of the ground. You can see there's an overall downward trend with a couple of interruptions each summer. That's sort of a seasonal change due to groundwater that's recharging and then draining away in the subsurface. So this seasonal trend superimposed on this gradual subsidence of about 2 to 3 centimeters per year, about an inch a year. That's been ongoing since 2015. If we move over to the west side of the caldera, the Mallard Lake Resurgent Dome, here is the result of a GPS station near Old Faithful. Again, vertical deformation over the last 2 years, and you can still see that gradual subsidence occurring over time, 2 to 3 centimeters a year, about an inch or so per year. You might notice that the signal gets quite a bit tighter here since about September of 2020, and that's because there was a fire that was near this GPS station, and some of the trees were cleared in that area to reduce the fuel load and hopefully keep the fire from becoming a real problem. And those trees were actually blocking some of the GPS signal from reaching the antenna, and you can see how the signal quality really improved when those trees were removed. So that was all due to fire preparation work in the Yellowstone area. And then finally, looking at the Norris Geyser Basin over the last 2 years, this is the Norris GPS station. There hasn't been a whole lot of change over the last 2 years. This offset right there is due to a change in equipment when a new antenna was put in, and there was a small bit of subsidence after that time. But really, since the beginning of 2020, there hasn't been any vertical motion at all in the Norris area. No uplift, no subsidence. And then finally, moving to Steamboat Geyser, everyone's favorite geyser, there were only 2 eruptions during the month of January. Now, this is the temperature record measured in the outflow channel for Steamboat. High temperatures and then dropping to low, and then high temperatures dropping to low. These high temperatures, and especially the periods of lots of little fluctuations, represent periods of intermittent minor eruptive activity. And then each period ends with a spike, and that's the major eruption. So one here on January 2nd, and then the second one of the month was on January 12th. And then after that, the geyser effectively goes dry, and you see the temperature drop back down to ambient, which, of course, because it's wintertime, is below 0 centigrade. And then since mid-January, we've seen this sort of ongoing minor activity at Steamboat. It hasn't culminated in a major eruption yet, but that seems likely at some point in early February. Well, that does it for the monthly update for February 1st of 2021. Now remember, if you have any questions at all, you can feel free to email us at yvowebteam, that's all one word, at usgs.gov. Stay safe, stay healthy, take care, and we will see you next month. Bye-bye.